Today I'll be demonstrating the effects of weathering and how wind can affect weathering. So the force of wind can change the surface of the earth in small ways by removing materials and wearing down rock surfaces. Rocks that are made of soft materials are broken down when they're hit by wind-blown pieces of sand or smaller pieces of rock. This kind of weathering isn't very strong because wind takes a lot of energy to move sand and rock. Each impact can break off small particles of the larger rock, leaving them in place. Fragments of rock left on the larger rock stay in place and wait for stronger forces such as water to carry them away, which would be erosion. Anytime erosion, when we use the word erosion, it involves movement. So weathering is the wearing down, and erosion has to do with the movement of that. So today, the purpose of this experiment is to simulate the effects of weathering by wind. The question we'll be forming a hypothesis about and in the end answering is, how does the size of rock carried by the wind affect the weathering of a larger rock? So my hypothesis is that if the size of the rock is bigger, then it will show more weathering. So for this experiment, we need fine and coarse sandpaper. We need 2 film canisters, and I've already labeled them fine and coarse because what we're going to do is cut off a piece of the sandpaper and line the insides of it, so that the part that will wear on it is facing the inside, so it's lined with that. We will also need sugar cubes and a timer. So the first thing you're going to do is line one of the film canisters with a strip of the sandpaper. All right, and I've already done that. You have coarse sandpaper and you have fine grade sandpaper, and then you label the outside. All right, so after you've done that, you take 1 sugar cube for each one, and you place it on the inside, and you put the cap on. All right, so then I'm going to start the timer for 1 minute. And then what we're going to do is we're going to swirl both of them, and we're going to create a table because we're going to do 5 trials, and you're going to have the size of the rock or the size of sandpaper, and put coarse and fine, and you have trial 1, 2, 3, 4, 5, and we're going to record our observations after each minute after swirling it. All right, so I'm going to start it for the first minute. I'm going to swirl. All right, it's important that after each time you're recording your observations and see how everything has changed. You also want to make sure you're swirling because you don't want to go back and forth, because that's going to be definitely more weathering is going to show, and it's not simulating the wind because the wind doesn't knock it back and forth and try to break it down that way. It's more of a softer kind of weathering. It's not very strong, like I said. I'm going to make sure we're just swirling. All right, 15 more seconds. You can change direction, it doesn't really matter. It's just important that you're swirling and not knocking it back and forth. All right, it's been 1 minute. All right, so what you're going to do is you're going to take the cap off, and you're going to look on the inside and kind of describe the sugar cube. How much sugar is on the inside? How much can you see is broken off? So you take a look, and when I look at the one on the fine canister, you can see a little bit, but it hasn't been very much. There's definitely more that's broken off for the coarse canister with the sandpaper. And so I'll record that in my observations, and I'm going to do that again, the swirling, 4 more times. So I have completed a total of 5 trials. At the end, I'm going to have the students answer some questions that relate to this activity, and they're going to see, using the data they have in their chart, whether their data they have in their observations support or disprove their hypothesis.